Hi class, welcome back. We're still in week 7. Now we're into lesson 7.2 and we're into the emulate phase of the biomimetic design process. Alright, for context here we whipped through all this. You just spent some time in the abstract phase taking what you discovered in nature and translating it, and so now you're ready for emulate. And emulate is where the design actually happens. I'm putting it in context, it looks like this. So if you did a good job with abstract, it sets you up perfectly for emulate. So I hope you did a good job in lesson 7.1. Alright, so the main thing about emulate is this is where the design happens. Okay, so emulate means emulating the functions and emulating the strategies you found in nature to perform the functions you want your design to form in your designs. Your design is emulating what you found in nature. And we use the word emulate instead of copy or mimic because, again, you're not trying to exactly copy what you see in nature. You're inspired by it, you learn from it, you're informed by it, you figure out the patterns, the principles, and then you figure out how can I make a design that captures what's going on in nature. And again, we can use all kinds of different, we don't have to emulate it exactly, okay? So that's why we use the word emulate instead of mimic. All right, so the idea here is once you have abstracted these, how the strategies actually work, you can brainstorm multiple solutions in your design. You can put together all kinds of different strategies in a way that you don't find in nature. So that's one of the beauties of biomimetic design is you don't have to just do it only things that nature does. You can weave in all kinds of different design solutions. See if you could meet multiple functions with each strategy, just like that's what emulating nature itself, right, is the multifunctionality. So see if once you design something using for one function, can you meet more functions with that strategy or by modifying the strategy? Once you're in the emulate phase, you may find yourself getting very quickly stuck. So go back, refer back to the discover phase, and consider, can I put together some different solutions that I found from different organisms in order to make my design work? And again, if you may have found this in the abstract phase, it's not simple, right? The discover phase is fun, right? You go, oh my gosh, there's a really cool thing that nature does. I'd like to do that in my design. It's an entirely different animal, excuse the pun, to actually emulate that. So you may need to go back and consult with biological experts. How does this actually work? And if you can't emulate the one strategy that you found, maybe another organism does it in a different way that you will be able to emulate. So you can go back and consult with biological experts. Also go back to your model and explore more strategies. So if you during the discover and abstract phase, when you discover how an organism or a system performs a given function, it may be that there's many different strategies being performed. Gosh, could you weave those strategies in since you're already emulating this thing? In addition to consulting biological experts, you're going to need to consult with technical experts. So again, it's one thing to understand how nature does whatever it is it's doing. It's another thing to copy that in a human design. You're going to need probably a whole suite of experts, of course, depending on what you're doing. But you may need, engineers, mechanical engineers, electrical engineers. You might need chemists. You might need biochemists. Well, you might need city planners. You might need, depending, of course, what you're doing. So you may need all kinds of technical experts to help you actually emulate. Now again, for your design project, you won't go that far, but just know that's part of the process. So going back to our example, which is what we're using for this week, is this Mirasol display. They discovered how the Morpho butterfly is able to create this vibrant color under direct sunlight. They figured out how they did it, how the butterfly does it. They figured out exactly technically how it's done, like how they could transfer the way the butterfly does it into technical terms, and then they emulated it into a display screen. Okay, so that's what it looks like. And again, there's some overlap in the abstract and emulate phase, but in emulate, you're actually putting it into a design. And again, to do that, you're going to have to dive deep into the science, perhaps dive deep into the engineering, depending on what you're doing. And then you're going to have to work with design experts to figure out, well, how do I put it into this kind of screen or this kind of screen, okay? So, and you know that, that design process as designers, but when you're doing biomimetics, you add these front-end things, and you still have to do a very difficult engineering process, okay? One of the things I want you to keep in mind is that when you learn biomimicry, and you say, oh, I'm going to design something using the design spiral, that's really great. Just as we've mentioned before, biomimicry itself is really fantastic at this front end for forcing you to do better designs, really identify the functions, so it's burst open your design space. And then in the process of trying to translate it to biology, it helps you even more understand what it is you're trying to do. And then you find all these amazing discoveries, right? That, again, burst open your design space. And then you have to translate back into the technical world. But when you get to the emulate phase, biomimicry doesn't do anything for you there except to say, you know, the tips and stuff that we just went through. So here, you kind of need to step away from biomimicry specifically. That's why we're calling this course Biomimetic Design, to kind of give a little bit broader picture. And you need other design and engineering tools. And I put the word conventional in parentheses because we don't want you to, you know, jump into, you know, using conventional materials and all that kind of stuff, and the conventional assumptions. That's why we're doing biomimicry or biomimetics and not conventional. However, you will need all the standard, you know, tools for calculations, design, engineering, okay? And there'll be a cycle, okay? So you're in the emulate phase, you're going to need to consult with this, use these tools, put it back in, see how you're doing. You might need to go back, okay? So just realize you're going to, in this process, you'll need to step away from, you know, emulate doesn't mean a whole lot unless you've got other skills to put behind it, okay? With that in mind, while you're emulating, and again, here's a power of that biomimetics brings to it, you need to think about, will nature's strategy work at the scale of your design? So if it's working at the scale of the butterfly, or the scale of a cell, or the scale at a landscape scale, will it work at the scale that your design needs to operate? Will it work under your operating conditions? Okay, so we talked about that earlier in when we're doing the identify and translate. We talked about turning your operating conditions into habitat conditions. So you have to reconsider that in the emulate phase. Whatever you discovered, will that work under your operating conditions, or were the habitat conditions part of the system that allowed the thing to work? So just consider that. And also, it's great to make fantastical designs, right? Because we need to know where we need to go to have sustainable designs. So you need to have vision of things yet to be that we can't make right now. So that's really important to do. But I also want you to be able to emulate using existing materials and technologies. We don't want your capacity as biomimetic designers to be limited to fantasy or how the world or how designs could be. We want you to be able to design for the here and now, as well as envision what really sustainable designs would be, okay? So for your project, I'm going to ask you to come up with a design that can be made or can be implemented with existing materials and technologies. A few tips, again, use your design skills here. You're all designers of one sort or another. Even if you're not, you know, by profession called a designer, use your skills that you have and bring them into the biomimetic design process. Be willing to ask an engineer, ask a biologist, you know, because you can't get through this phase without it. That's biomimetic design is all about the pairing up biologists and the whole suite of them with, I'm calling this engineer, but it could be any kind of designer, technical people, okay? So that's it. Putting those two things together is the power, so be sure you ask those people. You may not really fall into one of those categories. And again, always ask, can you perform another function? That's part of how you get sustainability out of these biomimetic designs. And as we mentioned in the discover phase, really rely on the spiraling. So when you're first emulating, do a quick design. Don't try and get to one big, huge final design this first time around. Just in your head, play with it a little bit, okay? Go through the spiral, a whole bunch of the small part of the spiral, a whole bunch of times, before you go, okay, I can kind of see where I'm going with this. And that might require going through all of the steps in the spiral a few times before you can really start to emulate. Okay, so leverage the power of the spiral. And as you did with the abstract phase, you're going to write up a project update report for the emulate phase. Okay, that's it. I really look forward to seeing your designs this week. These are just baby designs. They don't. You can have plenty of time later to work on your final design project. These are just to get you some practice. Okay? All right, so I will see you next week.